faster than the space-time fabric can keep up with it, and it'll just rip. I'm terrified by this. At this moment, our night sky is changing rapidly, and in just a matter of decades, if not years, it might become completely unrecognizable. Around the world, astronomers are sounding the alarm. Experts like Neil deGrasse Tyson have recently announced that the explosion of Polaris and the trail behind it is quite frightening. Long ago, Polaris, known as the North Star, remained constant in our night sky, serving as a crucial point of reference for astronomers and navigators. However, this might soon change, altering our night sky and astronomical measurements indefinitely. Let's delve into the significance of this threat and its implications for all of us. Join us as we uncover the story of Polaris. Polaris is getting close to its end after centuries of advising astronomers and mariners alike, holding a revered position as a guiding light. Its unwavering presence in the night sky has been essential for navigation, but this stability may soon be disrupted. In September 2023, a research paper presented by the esteemed Royal Astronomical Society cast doubt on the fate of this celestial luminary. Polaris is on the brink of exploding, potentially vanishing from the night sky forever. Before we explore the consequences of this revelation, let's understand more about Polaris. Also known as the North Star or Pole Star, Polaris is unique because it is close to the celestial North Pole. Situated almost directly above Earth's North Pole, it appears nearly stationary in the northern sky. Found in the constellation Ursa Minor, the Little Dipper, Polaris shines as a moderately bright yellow-white supergiant star, much larger and brighter than our Sun. It is not a solitary star but part of a complex system of three stars, Polaris A and Polaris B forming a binary pair, with Polaris B orbiting them. The interactions between these stars create gravitational forces that shape their orbits and influence their behavior. Any disruptions in these interactions can lead to irregular variations in the star's brightness or pulsation. However, the exact mechanisms behind these interactions remain unclear. Polaris is located approximately 323 light-years away from Earth, meaning the light we see today began its journey over 3 centuries ago. Thus, if Polaris exploded now, we wouldn't observe it until over 300 years later. It's even possible that Polaris has already exploded, and we are yet to witness the light produced by that event. Throughout history, the North Star has held immense cultural, navigational, and symbolic significance. Its stability and fixed position made it an invaluable aid for ancient navigators, guiding them across land and sea. Symbolically, Polaris represented permanence and guidance, remaining steadfast amidst the ever-evolving night sky. For astronomers, Polaris has served as a crucial reference point in the study of space and time. As a variable star, its periodic variations in brightness have provided valuable insights into stellar properties. These pulsations follow an established pattern, making it easier to predict its behavior. However, recently, Polaris has strayed from its expected behavior. Irregularities in its pulsation cycle have puzzled astronomers, leading to a closer examination of this celestial anomaly. Instead of its usual predictable pattern, Polaris has begun to exhibit erratic cycles of dimming and brightening. Scientists are now raising concerns that the star may be nearing its expiration date. This is consistent with observations of stars nearing their end, the gradual elongation of Polaris's pulsation period, which was once stable. This can be attributed to interactions within its star system. An annual increase in the pulsation duration of 4.5 seconds may seem insignificant, but it holds major implications. Some astronomers suggest that gravitational interactions between the Polaris stars could be causing these fluctuations in its atmospheric conditions, which directly impact its pulsation patterns. However, others are more alarmed, believing that similarities between Polaris and Betelgeuse suggest the star is on the brink of exploding. The similarities between Polaris's behavior and that of Betelgeuse, another notable star in the Orion constellation, are striking. Both stars have demonstrated perplexing irregularities in their luminosity, raising concerns about potential explosions. Stars in their twilight stages often display such anomalies before reaching the final stages of their life cycles. While NASA has expressed heightened concern about Betelgeuse, similar attention has not been explicitly directed at Polaris, even though it is also nearing the end of its life cycle. As a star moves through various phases, the main sequence phase, the red giant phase, and, ultimately, the supernova explosion, scientists predict that Polaris has entered the phase of helium depletion. The irregularities in Polaris's behavior align with patterns observed in stars in their twilight phases. However, definitive signs of an impending supernova remain inconclusive. Astronomers are diligently analyzing these irregularities to determine Polaris's fate. If Polaris were to go supernova, it would likely be a spectacular event in our sky, potentially outshining the moon and becoming one of the brightest objects visible for days, weeks, or even months. Its explosion could significantly alter the night sky, temporarily reshaping our perception of familiar constellations like the Big Dipper and Ursa Minor. Rest assured, Earth would likely be perfectly safe if Polaris were to explode. Its size and distance from us make it unlikely to pose any direct threat. While a Polaris explosion might not be as visually spectacular as that of Betelgeuse, it could still be visible to the naked eye for a considerable time, surpassing even nearby stars in brightness. Astronomers and observatories would undoubtedly take notice, sparking immense interest within the scientific community and among stargazers worldwide. However, its specific visibility and impact on Earth's atmosphere would be far less significant than that of a closer supernova event. But what about Polaris itself? What will become of it following a potential supernova event? Unlike giant stars that end their lives in a supernova explosion, this is unlikely to be the case for Polaris. When a massive star explodes in a supernova, its core undergoes a complete collapse, triggering an intense shock wave that leads to a violent explosion. However, Polaris is not massive enough to undergo such a catastrophic event. Instead, when Polaris runs out of nuclear fuel, it will shed its outer layers and transform into a white dwarf. This transformation will not result in a dramatic supernova but rather a peaceful transition into a small, dense stellar remnant. A white dwarf is the remnant of a low or medium mass star that has exhausted its nuclear fuel. These remnants are extremely dense, roughly the same mass as the Sun but compressed to the size of Earth. When this happens, we will no longer be able to see Polaris as we do today. Comparing the anticipated fate of Polaris with historical supernova occurrences provides valuable insights into stellar evolution. Events like SN 1054, SN 1987A, SN 2014J, and SN 2011F have offered crucial data for understanding how stars end their life cycles. By studying past supernovae, astronomers can better predict Polaris's future. However, unlike the dramatic remnants of SN 1054, such as the Crab Nebula, Polaris will likely fade quietly into obscurity as a white dwarf rather than leaving behind a bright and expanding nebula. This means that, while Polaris's eventual demise will significantly impact astronomical measurements and navigation, it won't create a spectacular explosion that reshapes the night sky in the same way as other supernovae. Instead, its fading light will gradually render it invisible to the naked eye, forcing future astronomers and navigators to rely on other reference points. The astronomical and cultural impact. The potential disappearance of Polaris carries more than just scientific consequences, it has deep cultural and historical significance. For centuries, Polaris has been a symbol of guidance, constancy, and stability. Its role as the North Star has inspired countless myths, navigators, and explorers. If Polaris were to vanish or dim significantly, it would mark the end of an era in celestial navigation. Future generations may no longer be able to rely on the North Star as a guiding light, prompting the need for alternative methods in navigation and astronomy. Furthermore, the loss of such an iconic star would leave a void in many cultural traditions that have long revered its unwavering presence in the sky. Ancient civilizations, sailors, and even modern travelers have used Polaris as a dependable beacon. Its disappearance would serve as a stark reminder of the ever-changing nature of our universe. The future of stellar observations. While Polaris's transformation may take centuries or even millennia to unfold, astronomers continue to monitor its behavior closely. Advanced telescopes, space observatories, and ongoing research efforts aim to understand how and when Polaris will reach its final stage. In the meantime, its irregular pulsations and brightness fluctuations remain a fascinating area of study. Scientists are using modern technology to refine their predictions, ensuring that when Polaris eventually fades, humanity will be prepared for the shift in our cosmic landscape. Though Polaris's end is inevitable, the knowledge gained from studying its life cycle will contribute to our understanding of stellar evolution. From ancient navigators to modern astronomers, Polaris has played an invaluable role in human history. Its legacy, even after its eventual transformation into a white dwarf, will endure as a cornerstone of our celestial knowledge. For now, we can still look up at the night sky and marvel at the North Star, appreciating its brilliance while it lasts. But as the universe constantly evolves, so too must our understanding of the stars that guide us. A single nebula that keeps expanding and emitting radiation across multiple wavelengths provides astronomers with a wide range of data. Similarly, the study of SN 1987A, observed in the massive luminous cloud, provided insights into the processes of nucleosynthesis and the dynamics of supernova remnants. Analyzing phenomena such as how nebulae are formed, the release of cosmic rays, and variations in luminance can provide valuable insights. Unique characteristics of Polaris and nebula structures like the Crab Nebula result from the material ejected during a supernova explosion interacting with surrounding interstellar gas and dust. This interaction enriches the interstellar medium with heavy elements and contributes to the cycle of stellar birth and death. In addition, the release of cosmic rays, high-energy particles accelerated by supernova shock waves, has implications for astrophysical processes and cosmic radiation environments. To arrive at a final comparison, scientists evaluate differences in the composition, mass, and speed of ejected materials between the anticipated Polaris burst and other observed events. This necessitates investigating the spectra and light curves from these occurrences and predicting comparable characteristics of the expected Polaris burst. Determining whether Polaris's burst might lead to the formation of nebulae or distinct elemental distributions enhances our understanding of its potential outcomes. Another crucial area of investigation involves evaluating the pulsational variability of stars nearing their end stages, akin to Polaris, against observed supernova precursors. This comparative analysis can help gauge similarities or deviations and provide insights into the burst mechanism. Pulsational variability in stars nearing the end of their lives could indicate internal instability or imminent catastrophic events that provide clues to the evolutionary processes leading to supernova explosions. Despite meticulous observations and extensive analysis, astronomers remain baffled by the irregularities observed in Polaris's behavior. Revealing the individual conditions driving these irregularities holds the key to advancing our comprehension of stellar evolution. Understanding the mechanisms behind Polaris's irregular pulsations requires collaboration across disciplines and the development of advanced theoretical models and observational techniques. The potential loss of Polaris as a crucial reference point in the night sky poses substantial concerns for astronomical endeavors. Ground-based telescopes and celestial measurements would require recalibration, impacting the precision of astronomical calculations. The absence of Polaris could also affect navigation systems and cultural practices reliant on celestial landmarks, underscoring the significance of this celestial event. The mysterious behavior exhibited by Polaris highlights the importance of monitoring stellar phenomena and encouraging collaboration to answer long-standing questions about stellar evolution. For a long time, Polaris has been a cosmic guidepost, but its eventual fate challenges our comprehension of stars and their dramatic transformations. As astronomers continue to monitor Polaris's erratic behavior, they grapple with the uncertainty surrounding its future. While the concept of a supernova might seem like the most dramatic conclusion for a star like Polaris, it is crucial to remember that not all massive stars end their lives in this manner. For a star to undergo a supernova, it must have enough mass, typically at least 8 times that of the Sun. Polaris, however, does not meet this threshold, meaning its final stages may unfold in a quieter manner. Rather than exploding in a violent supernova, Polaris is more likely to experience a change that is significantly less catastrophic. As Polaris exhausts its nuclear fuel, it will shed its outer layers, which will cool and shrink over time, eventually becoming a white dwarf. This is a common fate for stars that are not massive enough to trigger a supernova. The white dwarf will continue to fade over time. Although it will no longer be visible to the naked eye, it will persist as a dense, compact remnant of its previous self. While this process may not be as visually spectacular as a supernova, it remains scientifically important. The transformation of stars like Polaris into white dwarfs is an essential part of the cosmic life cycle. The material expelled by the star during this process will enrich the interstellar medium with heavy elements that may later be incorporated into new stars, planets, and even life forms. The loss of Polaris in the night sky would have profound implications not only for astronomers but also for those who have relied on it for centuries for navigation. Its fixed position as the North Star has made it an essential reference point, especially in the northern hemisphere, where it has guided sailors, explorers, and travelers. For many, its disappearance would symbolize the loss of an anchor in the heavens. However, astronomers and navigators have adapted to other methods of space navigation. Though the absence of Polaris would be a notable change, humanity would adjust. In the meantime, astronomers will continue monitoring the behavior of Polaris and similar stars. Technological advancements and the development of more precise instruments mean that we are better equipped than ever before to track subtle changes in these stars and predict their future behavior. The eventual disappearance of Polaris will serve as a reminder of the ever-changing, dynamic nature of the universe. Even the stars we once thought to be fixed and unchanging have their own life cycles, transitioning between periods of stability and transformation. The ongoing study of stars like Polaris provides vital insights into the broader mechanisms of stellar evolution. Understanding the processes that lead to the formation of white dwarfs, supernovae, and other stellar remnants deepens our comprehension of cosmic evolution. Though the Sun will follow a different path, eventually evolving into a red giant before shedding its outer layers and leaving behind a white dwarf, studying stars like Polaris helps us piece together the cosmic puzzle. On a cosmic scale, the death of Polaris will likely be a relatively quiet event compared to a supernova explosion. However, for astronomers, it will mark an important shift in our understanding of stellar life cycles and the intricate forces governing their behavior. It will also mark the end of an era for stargazers who have long relied on Polaris as a constant in the night sky. The eventual fading of Polaris will not only alter our perception of the night sky but also influence ongoing research into stellar evolution. As a Cepheid variable star, Polaris has served as a crucial calibration point for measuring cosmic distances. Its pulsations have provided astronomers with a reliable standard candle to determine distances to other celestial objects. With its transformation, the scientific community may need to refine existing models or identify alternative reference stars to maintain accuracy in cosmic measurements. The study of Cepheid variables like Polaris has been fundamental to our understanding of the expanding universe. These stars exhibit a direct relationship between their pulsation periods and intrinsic luminosities, allowing astronomers to calculate vast cosmic distances. If Polaris undergoes significant changes or ceases to function as a reference point, it could necessitate adjustments in our cosmic distance ladder, which forms the foundation of many astronomical calculations. Beyond its scientific significance, Polaris holds deep cultural and historical meaning. Throughout history, civilizations have relied on the North Star for navigation, storytelling, and spiritual symbolism. Ancient mariners used Polaris to traverse vast oceans, and explorers depended on its steadfast position in the sky. Its loss, or even a significant dimming, could mark a symbolic shift, reminding humanity of the impermanence of even the most seemingly constant celestial bodies. Despite the potential for change, astronomers are optimistic about uncovering new insights into the fate of Polaris. Advanced telescopes and space observatories are continuously improving our ability to observe and predict stellar transformations. Instruments like the James Webb Space Telescope and next-generation ground-based observatories will allow scientists to analyze the finer details of Polaris's evolution, offering a clearer picture of its future. If Polaris does not end in a spectacular supernova, its gradual transformation will still serve as a valuable case study in stellar aging. The process of a massive star shedding its outer layers, cooling, and settling into a white dwarf provides critical information about the later stages of stellar life cycles. By closely monitoring this transformation, astronomers can refine models of stellar evolution, offering broader insights into the fate of stars across the universe. For now, Polaris remains a luminous beacon in the night sky, continuing to guide both navigators and scientists. Its fate, while uncertain, highlights the dynamic nature of the cosmos. As our understanding of stellar evolution deepens, so too does our appreciation for the intricate, ever-changing forces that shape the universe. Though the North Star may one day fade from its role as a guiding light, the knowledge gained from its study will illuminate the mysteries of the cosmos for generations to come.